Okay, hello everyone, I'm Lydia, and in this video I'm gonna explain problem 1 of the real midterm. This is my fourth attempt or something, but never mind, we're just going to jump right into it. So for 1A, we're drawing the left resonance structure with all lone pairs and formal charges. So in order to determine how many lone pairs there are, you have to notice that every single atom basically have to have an octet, which means they're supposed to have 8 electrons or 4 bonds surrounding the atom. So for carbon right here, it has 3 bonds, which means they're missing 1 lone pair. So we just add into it. Let's just clear things up. And for nitrogen in the middle, there are 4 bonds, so this is good. Okay, so for the nitrogen on the right here, we have only 3 bonds connected to it, so which means we have to add an extra lone pair just to make it an octet. And in terms of formal charges, you can see the equation right here. Basically what that means is formal charge equals to group numbers minus bond numbers and electron numbers. So this is group, and this is bonds, and this is basically electrons. So in order to know the group number, we have to refer to the periodic table, which is right up here. Okay, so group number for carbon is so here's 1, 2, 3, 4, 5, 6, 7, 8. So carbon is group number 14, which we only count for the 4. So it's 4. So for chart, carbon is 4 minus bond number is 1, 2, 3, and minus electron valence electron. There is a not valence electron, but the pair of electrons has 2 electrons within it. So this is 4 minus 3 minus 2 is -1. So here is the negative sign on the carbon. And in terms of nitrogen, I'm gonna write it up here. And the group number is right here. It's group 15. So we will do it as 5 minus bond number 1. Let's just clear here up. Whoops. Okay, so the middle central nitrogen is 5 minus 4 minus 0, which is +1. So here we have +1 for our middle central nitrogen. And for the central, let's just send central nitrogen. And the last one is the on the right hand side, right nitrogen. We have same 5 minus 3 bonds minus 2 electrons, which will have 5 minus 3 minus 2 is 0, so it's 0 formal charge, which we don't write anything on it. Okay, so just copy the whole thing onto the answer sheet. That's our answer. So we're done. No, look at that, I forgot one thing. So the most important thing is always to highlight everything that the question just asked. Like me, I forgot to put the hybridization of the central nitrogen. So in this case, glad I highlighted it and I didn't forget. So the central nitrogen, the hybridization of central nitrogen is, how can we determine that? We just need to see how many atoms does the nitrogen connected to. So in this case, we have two atoms connected to the nitrogen, so which makes the central nitrogen hybridization to be sp hybridized. Let me just rewrite it. Sp hybridized. So yeah, and that's all for question 1a. And on to question 1b. We have, again, draw the right resonance structure with lone pairs, formal charges, and most importantly, do not forget the hybridization of central nitrogen. So again, we can use another color. Which color would I use? Whatever, I just use this, yellow. And again, to determine the lone pairs, we have to see whether the atom has an octet or not. So for carbon, we had an octet, which is like four bonds connected to it, so we're good. And for the middle nitrogen, we have also 4 bonds, so we're good as well. For the right-hand side nitrogen, right here, we are missing 2 bonds, which means we are missing 4 electrons. So we just add 4 electrons right here, and there are like 2 lone pairs. So for lone pairs, we're good. And in terms of formal charges, we'll just do it again for the carbon right here. It's 4 group number minus bonds. How many bonds are there? 4. 1, 2, 3, 4. And we just minus whatever electron it has, like it's 0. In this case, it's 0, which the formal charge would be 0. Let's just write this. Okay. And the mid nitrogen, we have it's in group 5 and minus whatever the bond it has. In this case is 4. 1, 2, 3, 4. And minus 0 because it has no lone pairs or any electrons on the outside. So around it. So in this case, the middle nitrogen, we have a +1. So which we will add a plus right here. And for the right hand, let's just write R, wait, no, that would confused. RIGHT, right nitrogen, we have, again, group 15, but we only use the 5. So group 15 minus 4. Oh, no, whoops, my bad. So not 4, but they're like 2 bonds. So minus 2, and there are 4 electrons. So we minus 4, which equals to 5 minus 2 minus 4 is, I can't do my math, -1. Okay, so we just add a negative right here, and we're done with the lone pairs and the formal charges. And in terms of hybridization of the central nitrogen, again, we look for the connecting atoms and see whether there is lone pairs or not. But in this case, there are no lone pairs for the middle nitrogen, So we are only looking for the the atoms connected to the central nitrogen. In this case, we only have 2. Okay, so which means the hybridization of the central nitrogen to be sp hybridized. Hopefully there's no question because I can't get a response. Okay, so in this case, I just get it. So this one is the answer for 1b. And this one is the answer for 1a. So continue to 1c. So we have to draw the resonance hybrid of this molecule. So go back to here. We have this and this. Normally, I would just, so we just draw the structure, like the basic structure of the molecule. And we can see, so, and here we have a lone pair and the other lone pair. Okay, so let's just draw this. So let me just so normally we would have like something like this, and without this. Wait, no. Normally we would have, it's here, not there. So we will have this and without this one. Also, we would have another kind of thing. Let me just copy and paste the thing right here. Copy and paste. Hopefully paste well. Okay, it does not. Let me just jump back to it and I'll just I'm so bad at this. Whatever. I'm just gonna do this. Draw it again. This time with like this. So in order for so what just happened was I basically redrew this and this. So yeah, and in order to draw the resonance hybrid, it's kind of hard for me to explain because sometimes I just draw it right away, and there are a lot of times where I don't even know how to explain, but I can do my best to explain what was going on here. So basically we wanted to get rid of this thing. So in order to like my brain needs to load. So the best resonance hybrid like structure would be like less formal charge and like be the optimal form. So in this case, for this nitrogen right here, it has 5, 4, 3, 2, 1. It has like -1. Oh yeah, negative. Okay, I forgot to put this on. Let me just so basically we wanted to get rid of the negative right here and to make it partial. So what we will do is to make this, and no, so we have to like move this here first. So it basically will look like this, right? Like the right portion of it. Okay, and so if it looks like this, we have to basically equally distribute what we have here. Forgot to add this. So we have to equally distribute the electrons right here. So in this case, we will basically just make it like this. Let me just rearrange what we have here. Oh, so convenient. Okay, so here we have another, just redraw the thing. Sorry, it takes too long to explain the third one. Okay, so the electron right here, the pair right here, we have to equally distribute among here, like among here, not among us, among here. Okay, so I can erase. Okay, and so how will we do that is by drawing the dash line like this, so that the electron, you can draw all the way across, but it doesn't matter if you don't. It's good with looks good either way, but for what I would do is to draw it like this, and just remember to place the thing like the formal charge. However, for the carbon right here, since this electrons are shared like among all here, we have to make it will be like a partial charge, a partial negative charge, because normally we have here is a full negative charge, a full negative formal charge, and we have here as well as a full negative formal charge. So we have to evenly distribute the formal charge, like the electrons, and as a result, the formal charge will no longer be full. It will be partial, so we just draw a little bird kind, like bird-like, like this kind of symbol right here to represent the partial charge. And there we go, our answer for 1C. Sorry it takes too long for me to just draw the stuff and to make it a lot of stuff to be organized. Yeah, so here we have, okay, here's the side note that my answer is. Yeah, so my answer is right here. So just making sure everything is in place, and I think it looks good. So which means this is correct. Good. Like check mark, and check mark. So thank you everyone for listening, like watching the video. If you didn't, that's fine. If you have, thanks a lot. And yeah, thank you. Bye.